Hi, I'm Hank Levy again. I'm director of the Paul G. Allen School. Very happy to have you here for our affiliates Research Day and also for the lunch and our lunch talk, which will be by Franzi Rosner, who's a professor in the Allen School. Just to say a few words about Franzi. She was an undergrad at University of Texas at Austin, where even as an undergrad, she was very engaged in research, actually in computer architecture. She was author of several papers at ISCA, the top architecture conference, even as an undergraduate. She got into every grad school in the country, even ones she didn't apply to, probably. And luckily chose to come here to University of Washington to work on research in computer security, received her PhD in 2014. And obviously, we hired her as a faculty member, something we've never done before or since, and are very happy we did. She's the winner of an MIT Technology Review TR35 award given to top innovators in the country under the age of 35, an NSF Career Award. She serves on DARPA ISAT, which is an advisory committee to DARPA. Very unusual for a junior person to be part of those meetings. And she's worked in a very broad range of computer security. Today she's going to talk about some of the recent work she's doing and some of the work she's done a little bit in the past. So, Franzi.
All right, thanks, Hank, for the nice intro, and thank you to all of you for being here. It's really nice to see some new faces and some people that I know. I co-direct the Security and Privacy Research Lab here in the Allen School, and so I wanted to give a little bit of an overview of kind of the type and the breadth of research that we do in that lab. So of course, as we all know, and I think agree, new technologies have the potential to tremendously benefit our lives. And just in the last few decades, just in the last few years, honestly, technology has completely transformed how we interact with each other, how we interact with the world, how we interact with the physical world even. But from a computer security and privacy perspective, what we think about is not just how all these technologies can be used for good, but also how they could be misused or how things can go wrong in unexpected ways. So what are the security and privacy risks that will arise as these new technologies develop? So in the security lab, we think about both existing technologies, so how do security and privacy risks threaten the end users of technologies today already, and how can we mitigate those issues? And also looking to the future, how is technology developing and how will new security and privacy issues arise that we have the opportunity to try to mitigate before those technologies are widespread? And in doing that, we use a broad range of methods and looking across the computing stack, looking at lots of different technologies. So one of the things that's exciting and also terrifying about computer security is that it's applicable to all of the different technologies and computing systems that we think about. So I'm going to give a few examples of the types of work that we do to illustrate this breadth. The first example is on security and privacy for emerging augmented reality technologies. This is a space that we've been working in for the last 5 or 6 years or so. Some of you may be familiar with these technologies. For those of you who aren't, the last few years have seen a tremendous advancement in augmented and virtual reality technologies, starting with smartphone-based AR games and platforms. Those are still popular and advancing today. And going from more simple heads-up displays like Google Glass to really impressive, immersive augmented reality platforms like the Microsoft HoloLens, the Magic Leap, and others. And again, these are all really exciting advancements that have the potential to change how people interact with each other and interact with the physical world. But our goal is to think not just about the things that might go right, but also the things that might go wrong. So what are the security and privacy issues that will arise that the designers of these technologies should be thinking about before they're already widespread and these issues arise in practice? To think about these issues, I'll start with kind of this abstract view of an augmented reality system. Often what we're thinking about is untrusted applications. So you can think of this as similar to a smartphone. You might have an app store or something like that. You trust the platform itself, but you want to enable arbitrary third-party developers to write applications for that platform. And then the question is, what can go wrong? What might those developers do either accidentally through bugs or intentionally through malice? And so we've looked at things kind of on both sides of this spectrum. For an augmented reality application to do interesting things, it first of all needs to take a lot of input from the physical world. So camera, audio, other types of sensor data to understand the physical world, and then ultimately overlay virtual content on the user's perception of that world. So we've looked at potential risks and started developing mitigations for issues on both sides of this pipeline. On the input side, there are, of course, a lot of privacy issues. Some of you might recall a few years ago when Google Glass came out, there were some may have been publicity stunts, but bars that took a stand that said, we will ban this type of continuous recording in our establishments. And so, of course, a big problem is how do we enable these AR applications that fundamentally need this kind of access to continuous sensor data? How do we enable that while still protecting the privacy of the users of these platforms and the bystanders? So one possible approach to this that we and others have taken is to say, okay, what's the role of the operating system in trying to mitigate these issues? Rather than, for instance, giving raw sensor data unrestricted to those potentially untrusted applications, what's the role of the operating system in setting permissions or restricting the sensor data given to those applications such that they can still carry out their intended functionality but limit the impact on privacy? These privacy issues have a lot of overlap, of course, with privacy issues in other systems, even just in smartphones. So it's actually the other side of this pipeline that I personally find more scary and more exciting to work on, which is the output side. So once these AR applications have gathered the sensor input, understood the world, now the goal is to augment the user's view of the world in some way. That may be by recognizing faces and labeling them with people's names. In an automotive setting, maybe highlighting pedestrians that are about to cross the street, showing you directions overlaid on the physical world, or of course games. And if we think with our computer security hats on about the dystopian future, we might end up with something like this, where lots of applications, for those of you who can't see this is kind of a dystopian view from an artistic rendition of what this might look like. If you have lots of applications that are showing you all sorts of content overlaid on your view of the physical world as you're trying to still interact with it. And so not only might we end up with this kind of dystopian clutter, we might have applications that do unintentionally or intentionally do targeted attacks. So for instance, taking the example of an augmented reality windshield, because there it's very clear how the physical world is impacted by some of these issues. A buggy or malicious application that's showing you things like directions or the current speed limit or highlighting other cars on the road. A buggy or malicious application here might do things like obscuring another application's virtual content, so obscuring or deceiving you about what the speed limit is. Unique to AR, it might obscure or deceive you about content in the physical world, so preventing you from seeing oncoming cars or pedestrians walking in the road. And then finally, these applications are unique in that they are not just overlaid on your view of the physical world, but they are very tightly coupled with your human brain and your perception of the world. So these applications might mount even lower level attacks like disrupting you physiologically somehow by startling you or taking advantage of different mental adaptations that your visual system makes. So for instance, some of you may see this, they might pop up spiders on your view of the world in your windshield. This would have worked better if this day had been yesterday on Halloween. So similarly, looking at this output side, the question we've been asking is what's the role of the platform or the operating system in anticipating and mitigating these types of risks? What should the interface be between applications wishing to display virtual content overlaid on a user's view of the world and the operating system's actual digital rendering? So we've done work thinking about exactly how that should look, rather than having applications have complete control of the user's view of the world by changing arbitrary pixels. We've thought about having a part of the operating system that's essentially a trusted output module that takes requests from applications, evaluates them potentially against some policies, and enforces those policies to have safety and security properties for the end user. So I'll show you a brief example from our prototype, some screenshots of how this might work. One of the challenges in designing this was realizing that the existing abstraction that we have in our traditional systems for how we display content, which is essentially Windows if you think about your desktops or your smartphone systems, the abstraction of a rectangular window doesn't work and doesn't allow us to have the fine-grained control over this content that we want. So in addressing this, we built a system called ARIA, which enforces these types of policies on AR applications to try to prevent applications from mounting these attacks I mentioned, startling the user, blocking important things in other applications, blocking important things in the physical world. So just to give you a few examples of how this might go well or poorly, these are screenshots from the kind of base condition. We implemented this with an AR simulator. So this is the virtual world that is standing in for what you should think of as the real world here. Then we can run multiple applications, simultaneously augmenting the user's view of the world on top of this. And those applications might do obnoxious things like plaster ads everywhere, or accidentally take up too much of the space of a user's vision, or block things from other applications. Our system can then enforce policies like don't block important real-world objects, or take up only a certain percentage of the user's display, the user's visual field. And so once we enforce these policies, we get much more well-behaved looking apps. And of course, there are many challenges in realizing this system and in balancing the functionality needs of applications with these types of policies. But the bottom line here is that augmented reality technologies have unique potential to transform our interactions with the physical world, and it's critical that we think about these issues in advance before the technologies are widespread and things actually go wrong. And what's exciting in this space is that we actually have the opportunity to do that because these technologies are still, while they are now realistic and commercially available to some extent, they're still malleable, and we have an opportunity to address these issues. A second example I want to give is around designing security and privacy enhancing systems for specific user groups. So of course, the human end user is an important component of any computing system, and in security in particular. And one of the things that we've been doing over the last few years is thinking not just about the generic end user, but also about specific user groups who might have unique security and privacy needs or constraints that make possible solutions intractable for them. And it's critical to understand these different user groups in designing for them so that we can build things that actually meet their security requirements and that they will actually use in the constraints of their daily work. I'll give you a couple of examples. One is around computer security for journalists. We've done a lot of work studying how journalists interact and communicate with their sources. They take very seriously their duty to protect their sources, but they also have a duty as journalists to gather information and report on that. So we've done a lot of work in this space, and I'll give you an example of one of the kinds of insights that came out of actually talking with and working with journalists that maybe as pure technologists we wouldn't have realized. One of those insights is that when journalists choose how to communicate with their sources, from a pure technical perspective, we might say, well, we can have encrypted messaging apps, we can have encrypted email. There are various solutions that maybe already exist or that we could design. The problem is that talking to journalists isn't sufficient. Journalists often rely on their sources to make decisions about how to communicate. The sources may not be tech savvy, often they're not. And so the journalists don't want to scare the sources away by saying, like, sure, we can talk, but we must use this particular encrypted communication technology that, by the way, you need to watch this 20-minute YouTube video to figure out how to use it. So to quote one of our participants, generally what we heard from journalists is that they'll say, we go with what the source is comfortable doing. That's generally what journalists would do rather than stepping in and being paternalistic about the choice of technology. So ultimately, this underscores the need to build more usable security tools in general. Another example that those of you who attended the security session this morning heard about was computer security for refugees. So we studied Seattle-based refugees that have come to the United States and have various challenges to how they use technology and computer security in particular that may be different from the challenges that we might traditionally think about for more generic end user groups. One such finding is that many security mechanisms actually make cultural assumptions, have US cultural assumptions embedded in them. One of those types of things is around password resets and security questions. If you think about the things that security questions tend to ask you, like the name of the street you grew up on, or perhaps birth dates or other pieces of information, this information is not necessarily relevant or even unique for people from other cultures, and so these questions don't actually serve their intended purpose. And so in the words of one of our participants, these were case managers working with refugees, the refugees might not be used to keeping this kind of information in their heads. They might make up answers to security questions and then forget them. So again, important to understand the user groups that we're actually designing for and their constraints and building systems that will work for them. And a big part of that is actually talking to those end users. So a lot of the work we do involves not just building the systems, but doing these kinds of user studies. I'll give one final example, which is an example of measuring security and privacy as it exists in the world today, not anticipating the technology, but actually seeing things that have maybe already gone wrong or risks that users already face. And that's around tracking and targeted advertising on the web. I think at this point it will be surprising to no one that you're tracked commonly as you browse the web. So you might visit a site like Zappos and check out some shoes, and then you'll see those shoes following you around the web everywhere you go, like on CNN or on The Onion. And this is a common experience. People usually chuckle when I give this example because we're just used to the fact that this is how it works now. And of course, this tracking has benefits. Better targeted advertisements have various benefits. It's the economic model that underlies the web. Personalization is good. Website analytics is also supported by these types of technologies. But there are also, of course, privacy concerns. This is something that we've worked on also for a number of years now. And we and others initially focused on privacy concerns with respect to the advertising platforms and the advertising ecosystem. But more recently, we've actually focused on a different potential adversary that is maybe a little bit surprising and maybe doesn't have the same kinds of incentives as these advertising platform providers do. And that is just the random individuals who might purchase ads. So for example, the high-level question we had was, as an individual buying ads, say with $1,000 or less, what information can I actually extract about people just through targeting ads at them? I'll give you a brief overview conceptually of how this works. Suppose I want to know, I know someone's email address, like alice@gmail.com, and I'd like to know how old Alice is. I can do that by buying ads targeted at Alice's email address, and then at a bunch of different ages. And then all I need to do is see from the advertising platform which of these ads is actually served. And that's the one that the advertising platform, knowing Alice's demographics, has chosen to show Alice. And so then I can conclude that her age is whatever ad was targeted. And because the advertising ecosystem actually has so much information that it either knows, has gathered, or can infer about people, this can enable an individual to actually extract a lot of private information. We conducted a case study with mobile advertisements in particular. These are ads that appear in different mobile apps. And we showed that an individual with $1,000 or less can do things like track the physical location of an individual. So the way you do that, again, is you target a bunch of ads at different fine-grained locations and a particular user, which is something that you can do. And then you observe which of these ads are actually served and use that to trace the path of that individual. Likewise, you can track which mobile apps the ads are shown in and infer things about the person's interests, potentially sexual orientation, other private attributes of that individual. So the bottom line here is specifically around the advertising ecosystem, that advertising platforms should think about how their platforms might be misused. Not how they themselves might use that information, but how others who are not regulated and cannot necessarily be trusted might use that information. And there's an inherent tension here in trying to balance the ability to do fine-grained targeting, which has some benefits, with these types of privacy concerns with respect to different adversaries. And of course, it underscores the broader point that in all of the systems that we build, we need to be thinking about ways in which they might be misused, ways in which the data might be used in some ways today, but in other unexpected ways tomorrow, and different types of adversaries, and how we can proactively design our systems to try to mitigate these types of issues. So this work, of course, was in collaboration with a lot of great people, both here in the Allen School, across campus, and at other universities. This is a photo of a subset of our lab going to ice cream earlier this year. And with that, I think we have a couple of minutes for questions if anybody has them. Otherwise, I'll be around today, and I'm happy to chat more later as well. Thank you.
We could take a couple questions, and I can run around and give the microphone to people if they have questions. So questions for Franzi? I'll start with one. Of course, the augmented reality one is pretty scary, and some of the things. How can we be sure that the people who are building cars or those things are actually taking this into consideration?
I think multiple answers. One is, if you are building such a system, I would love to talk to you. More seriously, I think the incentives are actually aligned. Security is always challenging because unless that's the goal of your product, it can get in the way of and is a resource balance question around building the features and getting your platform actually to be something that developers and users adopt. But I also think that no company wants to be the company that has the headline that their AR system caused someone physical harm. So I think the incentives are aligned, and it's a matter of trying to think about these things proactively in advance. And so what we've been trying to do, and also talking with people at various companies, is raise these issues and have these questions be part of the design process earlier rather than later.
Thanks. Other questions? Did we feed you too much? Okay, there's a question. Hang on.
With our phones and smart homes and all of the fun devices that surround us, what kind of insight can you give us into having confidence that the signals that are being collected are things that we would be willing to share, and that, for example, audio is not being passed along to malicious actors or to eavesdroppers, for example?
Yeah, it's a good question. The question is about how can we be sure that with all of the devices that proliferate in our lives that we can have some assurance about the way our data is being collected and used. I think that's a really hard question. It's kind of like the million-dollar question. There's been a lot of work, and we've done work also previously specifically on smartphone permissions. We're thinking about that still in the context of smart homes. Again, there are a lot of tensions here in how do you design a system that enables the good applications to do all the great things that they want while allowing users to control their own data, understand where their data goes, react to potential compromises, things like that. It's a great question, and I don't have a really clear answer for you. I think it's always a matter of trying to learn from the previous technologies, but also realizing that our previous solutions may not translate. A good example is the augmented reality case where these systems fundamentally need long-term sensor data to do something interesting. With smartphones, we could have solutions that say, for instance, apps should only be doing things when users are actively interacting with those apps, and that's an intuitive way to try to restrict that if you can do so automatically. That idea doesn't translate well when in smart homes or AR where continuous sensor data is useful. So I think there's a need to think more carefully about what the user experience and user interface side of the control question is, and also monitoring of these types of measurement studies, monitoring what is actually going on in the ecosystem, and is it what people expect, is it even what the manufacturers of the devices expect?
Other questions? Okay, you have about 10 minutes. The next session starts at 1:30. Let's thank Franzi again.